Avery. Brandon.
Here.
Isaiah.
Here.
Todd.
He's here.
Wait a minute. Didn't get somebody. Oh. Let's look at chapter 4. Which is decision structures and Boolean logic. Basically, what you're learning about in chapter 4 is just how to make decisions. And that there's two big ones on that. Let's see what we can do in here. So within Flogorithm, you're just going to have one of the choices available to you. The other one, using case structure, I'm not sure which assignments I gave y'all. If we do need case structure on it, you're going to have to just draw that one out. Because it doesn't have in Flogorithm case structure. Still want to play with Rapture and see if some of this stuff will work in there. Because they don't have cases in here. But with the decision, just on a basic simple decision box, you've got a question here, which is your if. What you're going to put is if in most languages. A lot of times if you were just drawing flow charts, you wouldn't even put the word if there. The fact it's a decision box, you know it's an if. Okay? But they're putting if into it.
How'd you do that in line, like the rectangle line that says false, true? Yeah.
When you choose the if decision, it does the whole thing for you.
Oh, okay.
Okay? Because the decision box has got to have more than one route of it. That's different than the other boxes we were looking at before. Okay? Because you've got a choice. And you've got to have at least two options for a choice. Normally, true, false is what you're going to look at it as, but you don't have to consider it as true, false, but something equivalent to true, false. Could be a yes, no, or whatever, okay? Everybody follow that part? So you're going to put your question here, and then you're going to tell it what to do each way. Now, you don't have to have something done both ways, okay? There doesn't have to be something special done in both of these routes, but both routes got to be there. So it could be you're saying if something occurs, do something. But if that doesn't occur, we don't want to do anything, so in that case, our false will stay just like it is right now with nothing in the line. Everybody follow on that? Could be the opposite way also. Could be something to do if it's not true, but nothing to do if it's true. So for instance, let's declare a variable named name. Which I'm going to make a string variable. Click OK. And then maybe my decision is if name, I think I can type it this way, but I'm not sure, equals what? Yeah. So now our decision is if the name equals what, we go this way. If the name's not equal to what, we go this way. So let's add an input box up there, and or let's just declare a name equal. Well, let's do an input. So we're going to whoops, that's output. I'll click input. I'm going to input name. Click OK. And then if name equals what, we want to print out a message that says perfect teacher. I know that's what y'all are just waiting to do your evaluation at the end of the semester so you can give me perfect scores, right? So now we've got something for it to do. Now if I run this little program here, watch what happens. I'll go to run it. It's asking for the name, but who I'm wanting to know about is Todd. Okay? Nothing happens.
Wow.
Did I tell it to do anything if it was Todd? I only told it to do something if it's what, right? So it ran successfully. So everybody follow on that? We didn't say anything about Todd, so we don't know if Todd's a perfect teacher or a lousy teacher or whatever. We didn't say anything about him. If I run it again, and it's asking for name again, so I'll put Watt in this time, hit enter, and it comes back and tells me perfect teacher. So the decision box is going to let us ask a question and do stuff based on that. Now, when you're doing it, take that back away again. You can do an exact comparison, like I did right here with an equal sign. And in this case, it really is equal, okay? As opposed to when I said when we use it in an assignment statement, it's really not equal, it's equivalent. So we can say something specific. We can use a greater than sign. We can use a less than sign. We can do a greater than or equal, a less than or equal, and we can also do a non-equal. Does everybody follow on that? And so some type of decision to it. It can even be a simple little question without doing that, but you really have to have that fully there. And their examples, they don't show like cold outside. It needs to be a comparison in it for when it goes into the programming language. When the program gets here, it evaluates that condition and then goes on whichever route depending on what that condition says. Is that condition true or is it false? So when we had entered Watt in here, it got here and it asked if name, the value of the variable name, is equal to Watt. Well, Watt's equal to Watt, so it came over here and did this. Now, you can do a number of items on each side. Okay, so you're not limited down in this whole section here to a number of commands you can put there. You can put a number of commands there on it. So you can build those through there. Non-equal is going to be, and I assume, let's see if that logarithm is using that one, because that varies by language on what symbols are. Because some languages, for non-equal, you put a less than and greater than sign. The book's telling you to use the exclamation point equal. I don't know if logarithm will accept that or not. It accepts it. Let's see if it runs. We'll put Todd in again, because Todd's not equal to Watt. And it now says Todd's a perfect teacher. So, explanation equal gives you non-equal. Does everybody follow on that? But you can combine the others together as you want. So you can do your greater than. And remember, with the greater than and less than sign, it's how much of the opening is there on which side tells you rather which is supposed to be the bigger or smaller. So that's greater than. So we're saying we want this side bigger than this side. And you got a bigger opening on those two lines on that side. Some people get confused on trying to remember which is the greater than, less than sign. Less than, we can do less than equal, greater than equal, and then they tell you on some languages it does use an equal for equal, but obviously logarithm works fine with just a single equal sign. But in C, I think it is, you have to do an equal instead of an equal. Also on these two right here, they're greater than equal and the less than equal. Depending on the language, the order those signs come in may be significant. Some languages say they have to be in a certain order. COBOL used to use them in this order, but I know some others use in other orders. So I tend to write them. I like to write them this way anyway, because that's the way we say it. We don't say equal or less than, we say greater than or equal to. So I tend to, but it depends on the language syntax. So you can do all of those combinations on it to go through and do on it. So that covers those. And I say the book is going to use the two equal signs for equal. But Logarithm's going to let you use one equal sign, and it depends on the language on which way you have to do that on it. Now, if you were drawing these for otherwise, like here where we have nothing here, quite often you'll see in other drawing places of it that you'll just see them draw a straight line down here with the false, but all routes out have to be labeled. So you have to label your routes. Does everybody follow on that? It does that for you automatically in Logarithm. It puts the true and the false and then just choose which one to build your situation on there. So that's your basic control structure. If you were doing it in an algorithm or in pseudocode, you'd have your if, the stuff that's the then falls right after it, then you'd have else, the stuff that falls and the else would fall, and then you'd have an end if marking the end of it. Same thing goes into your programming languages. It has to mark the end of the whole if construct. I already showed you how to compare strings. It works just like working with numbers. It's just if you're comparing to a number, you just put the number there, just like we've already seen in assignment statements or whatever. If it's a string, we put the string value inside quotation marks. So we're stating the same rules we've already had on that, but they go through and talk a little bit about that for a moment. And then they mention to you about order on it. It is going to be doing it by their ASCII codes. So when you compare strings on it, uppercase letters have a smaller value than lowercase letters. And numbers come before letters in a orderly form. So it's going to see if you had in the same column, numbers are going to be less than uppercase letters, and uppercase letters are actually less than lowercase letters. An uppercase letter is not equal to a lowercase letter. So if we ran this program with Watt with lowercase w, we'll see that that person's not a perfect instructor, because it should be case sensitive. Well, it's not case sensitive. In your programming languages, it's normally case sensitive, but Logarithm's not case sensitive on that. They don't quite have that quite right there. It should be case sensitive. You can build ifs within ifs, so you can make decisions within decisions. So in this case, and you could do them on either side, but we could have an if within the false, and we can put another if within there. The only way this if gets done is if this one's false. Y'all follow on that? If this is false, that comes to here, does this one, sees what the comparison is, and then does whatever that is. You can nest those as much as you need to nest them. Just be careful on not nesting too much, but you do have needs to nest a number of them. They show you in the book of determining letter grades of a bunch of ifs on page 147. All right, y'all follow how to do that? Y'all see how to do it and how to do it in Logarithm too? So that I didn't just tell you about it this time, I actually showed it to you in Logarithm. So we may change like y'all want it. Next one is the case structure, which, like I said, you can't do there in Flogarhythm. With it, because here in Flogarhythm, all we can have on our decision here is two choices. You may well have a number of choices. Okay? Does everybody follow on that? You would use a decision box to do that also. And we would have what it is we're comparing, that we're looking at, that we've got a number of choices of whatever value is in here. So, for instance, I think of something right off the bat. It's got several choices. Usually I can think of something, but I can't think of anything at the moment. So they've said they want to print out what month it is. You've input the number of the month, and you want to print out the name of the month. Your decision is on month, but you're not putting the full decision right there like you did in the if. Everybody got that? Month is what we're looking at. Instead of multiple lines coming out, we're going to have one line come out of the bottom, split into a number of lines coming off of it, which can be 2 or more. Usually it's 3 or more. If it was 2, you just do an if statement. Okay? Label each one of these when they get done. So in that case, month, there's going to be a 1, a 2, a 3, a 4, a 5, etc. We'd have 12 of those across there. Maybe we just want to print out what the month is. If you type in the number of the month, it comes back and tells you what month it is. So if you type in a 2, what's it going to give me back?
February.
February. Okay? And that's all we wanted to do special right there. So then we have them all come back together. And read on down to the next point in our flowchart. Does everybody follow on that? So when you've got a number of choices to make on it, you can list the choices here for them. And depending on what the choice is, it does that part of the code. When it's a number of choices, that one will work better. Actually, for doing that grade one, this will work nicely too, because you could actually do this first one as being greater than or equal to 90, print an A. This one would be greater than or equal to 80, print a B. Greater than or equal to 70, print a C. Greater than or equal to 60, print a D. And you can have a catch-all as your last one, which is the default. I'm just trying to remember how they label it. That is, if nothing else matches, print an F. I'll see you on that. And then in the code, you would actually tell it each of these options on case. But you're not worried about the code in here. But in the flow chart, you give it all the choices across there and include a default on it normally. If you don't put the default over there and it gets there and it has a value different than any of the other choices, your program's going to bomb out. Everybody follow on that on case structure? Now, if one of your assignments, and like I say, I don't remember which assignments I gave y'all. I don't think you need it for it. I'm trying to remember which ones they were. Let me flip back over there and see. Assignments. On 4. One, 4, and 7. 7 you don't need. 7 you can do nested ifs. Four, you don't need it. And 1 you can do with all ifs, so you don't need to use the case on it. All right, questions on all of that? Y'all got all of that? The other one they show you in the chapter is logical operators. Because beyond what we mentioned right here, that group, you also have ands and ors. You can say something or something, okay, as your comparison. So you can also compare to see if it is something and something, or if it's something or something. Or that you can connect a couple of expressions. If month equals January and bill greater than $500, we won't charge them a payment. Okay? If you do and, when you connect two logical operations, if you do and on it, what does and require it to be? To be true. Anybody know? And says both expressions have to be true for it to be true. If either expression is false, the whole thing's false. So if the first one's false, it knows immediately and it's something and something. First one's false, it knows immediately it's false. First one's true, it's got to look at the second one and see if it's true or false. If it is true, since they're both true, it would be true. If either one of them is false, it's false. Or says if either one of them is true, the condition is true. Okay? That's why you'll see some legal things and stuff all say and/or, is they're saying if it's any combination, they're really saying or in that context. Okay? But if you've got something that it says this and this, they both have to be true for it to be true. If it says this or this, if either condition is true, it's true. Okay? Questions on the and or? But sometimes that confuses people on getting and the or straight there. Not just says take the inverse of whatever your condition is. It just reverses it. So if you had a condition there and you put not in front of it, you're saying you're actually looking for the opposite of what value it comes back with. So if it comes back with true, you see it as false, and then using that into your conditions also.
What about else if? Else if statements?
The else if?
Yeah. You have
Okay.
If else, and then you have else if. And I'm not
Actually,
sure what
we touched that one, but we didn't I didn't say anything on it. Let's go back to flow rhythm. That's your else if. Is your if
Else.
with another if inside the else.
Okay.
Okay? You can have an if inside the true, the inside also, but then in most of the languages, you don't actually put the word then.
Yeah.
So you have an if, and then you have an if.
Usually then comes with a function. If you create a function, then you have to make an if-then statement.
Hmm?
If you create a function and it's trying to find something specific, you would create an if-then statement. At least this is how it is in Lua.
Because we could put another if right here.
Yeah.
And then it's an if within the then. So you can nest them on either side. But when you're coding it, you'd actually end up with if whatever's the true side, then doesn't normally get put there. That's just because you always have that side, so they don't put thens on it. But then the else you'd have, and you'd have the conditions that occurred. However, if it's another if inside here, if it was direct one without any other statements inside that else, you could go with else if, or else you just have, in that case, an if right there, stuff, and else, stuff, and then an end if for this if, and an end if to end that one. Does that answer your question?
Yes.
Okay? The other one they do mention to you at the very end of the chapter, which usually is an advanced topic on programming, you can make variables, Boolean variables, which means they have values of yes and no or true and false is the only values they can have of it. And remember, in Flogarhythm, you can actually make that type variable. And all you can assign to it is either a yes, no, true, false to it. Okay? In which case, that's saying, like we were talking about going through your comparison, that then you're saying that here it is that it's either true or it's false. For your basic programming stuff, you don't get too much into that one, but you can but you'll use those as flags out there that you can turn on a Boolean variable and use it as a flag to yourself of knowing what the condition is about something. That we could have set a condition inside in here on each side, and we could have said that good teacher equals true, good teacher equals false, come back together. We still know what the condition result of this comparison is while we go back to common, going on down by just looking at good teacher variable, instead of having to build the code both directions. Okay? So those can come in handy at times of using them as flags or switches. All right, questions on all of that? Now, back in chapter 3, how many of you have turned in your programs? That's all that I thought had turned in your programs. And actually, I think you're the only one in both classes, or as of the other day. Y'all need to get the chapter 3 ones turned in. Remember what I said I'm going to do first thing. So I'm going to go through, look at them, and see if you've got anything wrong, and send you back a note about what needs correcting on them. And that's why I haven't touched them yet, is because I only got one so far, and I want to grade more than one at a time. Okay? So my intentions completely is that I'll definitely grade on them tomorrow. So get those in. They're due today, remember. Okay? And then, but remember also, one, if you're having a problem, ask me questions. And two, that in the case of this one, that I will return it with comments on it about what you need to fix on it and for you to fix and resubmit it. Okay? Since we're limited in chapter 3 that you can draw it out in here, but you can't completely represent it on how it's supposed to handle the variables back and forth. Of transferring them to the module and back and forth, that logarithm doesn't exactly work perfect on it, so we'll have to work around that one on it. Questions on that? All right, we have covered all of chapter 4 today. Pay attention now. Wednesday, we're supposed to still be on chapter 4. I've got a meeting I would like to go to up in Collegedale, lunchtime Wednesday. Do y'all want to meet on Wednesday or not? Because if y'all want to have class here Wednesday, I'll be here. But if y'all don't see any need to have class on Wednesday, then I've got that I would like to do.
I think what we're going to plan on doing is, like, I ain't going to speak for them, but I think what I know what's going to happen is I'm still going to come here just so I can get out of my house and away from everything.
And that's no problem. You can do that.
And I'm going to come here and still work on this stuff.
Mm-hmm.
But I mean, if I have any questions, I can always email you. And you'll be looking your
And-
email, right?
And I won't be on email during that time period, obviously.
But if we ever get stuck, we can always save out my USB.
And then
so.
the other part is I should be back here. I would imagine I'll be back here by 1:30 or so anyway,
Okay.
or shortly thereafter, because their meeting should only run an hour. Because the Collegedale Club just got to 50 members and are celebrating getting to 50 members. And also Congressman Fleischner, whatever his name is. The congressman from up there in Chattanooga is speaking to their club that day too. But meetings shouldn't run any more than an hour because they're taking their lunch break from business to go to their meeting. So they're all going to want to leave after an hour anyway. So in your case, I would most likely be back here before you leave anyway.
Okay.
But either way, I will answer your emails. Okay? Is that there later in the afternoon, I'll answer them. But if there's not a need, if y'all don't need me to come in and lecture on it some more or whatever, or meet with y'all, then I'll do that. But if y'all need me here or want me here, I'll stay here. Does everybody follow on that?
Yeah.
Y'all got that, Todd and Brendan? You got it on what I'm saying?
Will the first class still meet?
First class still meet.
Alright.
It's just, I'm going to aim for us to probably quit by 10 after or so to give me a couple of more minutes to get to Collegedale. Okay? Because it starts at noon up there and 30 minutes will get me to Collegedale. Or less than that actually. But y'all know the interstate.
Yep. I was on it.
No telling what it's possible I won't get to the meeting also. That I could get caught in a traffic jam and be an hour before I could get to Collegedale.
I was on the interstate last week. I had my emergency brake on the whole time. Didn't even notice. And my brakes didn't work whenever I got to the exit. So, yeah.
Did you get stopped?
Not necessarily right then and there. I almost ran into a truck, and I turned real hard and almost ran into the ditch on the side of the interstate. I was scared out of my mind the whole time. Threw it in neutral. It was a good thing. Whenever I took that turn, though, my tires screeched really loud. But yeah, I eventually got stopped at the I can't remember what it is, but it's like the cylinders for the brake fluid.
Mm-hmm.
They were pretty much popped, like the sides, the rubber sides. They were just bursted out, and it was just sucking in air and just screwing up the brake fluid. So I got new cylinders and ended up squeezing out all that air, the brake fluid. That's why I wasn't here all last week.
Gotta be careful with brakes.
Yeah. I even got my loader's turn.
Well, at least you didn't hit anything.
I didn't expect you to, I guess. It's like a child, it's like a little baby.
The other one's downshifting to get you slowed down some. All right, any other questions on all of that?
We're doing one, well, they're doing another one. We're doing one from last week right now.
Okay, so y'all are working on those that you're supposed to have turned in to me by tonight.
Yeah. Well, the problem is that I don't know. Well,
Like, how they know that they gotta put the amount for the loan payment? Because it's not sure, it's not letting you know, like,
Because you're gonna just have, the only thing you can do on those is you're gonna just have
Like,
to lock
enter the
it,
numbers?
because it's not gonna,
What should I send it here?
all right, which one is this?
this is the one for this one right here.
this giving is not all I don't know.
Now, you've got a number of things you gotta input, remember,
Yeah. So I'm gonna include every single one?
because you gotta input all of those, yeah. But you're not calculating any of these. Okay? Now, this is chapter building.
Yeah.
Now, you're supposed to do it as a modular one, so
So it's not like.
you're doing it non-modular right now, okay? Now, what you're going to need to do is spin off different things into different modules. Similar to like we did.
There we go. Okay, it's working now.
Because we gotta do it more.
You got to do it in module, remember? So like when you input the tires,
Okay, so I got
Call
output your date. Is in
module
the
for
magic.
tires, and
Output
you
your
have
month.
input tires in
Yeah, you
it.
don't have to do all that. Oh, yeah.
So then you're gonna have to put, instead of that box, you're gonna call box.
So you can just put it on that. So just like.
Whatever you're gonna call the function, you're gonna call.
I'm doing the tires.
Okay?
So we're replacing that.
Uh-huh.
Now, read out your input tires right
We need-
there. Highlight it, you don't want to read it.
So we're replacing the input with the call boxes?
Now. Okay,
So I
you got
put
those
wrong.
things up there. I got it all there. All right, let's go back down to that
Here,
one.
numbers, not magic.
Yeah.
Okay, so now you've got a module called tires. Create a module. Go up to the top. It's called tires. And you actually don't have any parameters. You're not passing anything over to there. You're going to return, put down that. You're going to return.
That'd be real, wouldn't
Yeah, real. And tires is what you're going to return. And this is where their stuff may not exactly work for you. Okay?
So,
In it? Okay.
This one.
All right, so now inside there, down between the two, put
Four
your,
dash four.
you're going to input tires, but also give yourself a message to tell you what it is you're inputting. So output a message first before the input. Output.
No, it's not there, but.
No, no, no. Output. Because you're going to put a message in. Put inner tires inside quotes.
And
That way we know what it is it's asking for, okay? And then on the input box, put that as tires. And we haven't declared tires. We still got to declare tires right before that. And it's got to be before the input. And we'll rid of that input box there. Yeah. All right. Now, that'll get you, so now go back over to the other, if we were gonna get this, it's not gonna really run, okay? Because you don't get the value back over to the other place because it's not returning on it. We can do it as a function type of return. So go up there to the top where it says name, where it says tires right now, over to the right. No. On the bar, there. No. And you can go back to the main part. Now you actually have the module. You don't have the modular, so you really ought to be, I have the inputs all. Either in separate modules or just having a module that allows you to enter them all. And then theoretically return those values, but Flowrhythm's not letting you do that.
So you gotta do like this for every single like
That's what you
oil,
need to do.
gas.
Mhm. Okay? Then you've got it in modules.
I have a question. How would you be able to say if it's equal to something, like a number between, say like,
That's where your and and or comes in. So, okay, so.
I want it to be between 10 and 19, so.
Okay. Greater than or equal,
Instead of equal signs.
and the greater than sign. And then equal sign. And. Now, do you want to use, no, you're not through yet, do a space. But you gotta get this whole thing in here, now you gotta tell it about the rest of it. All right, is it just,
Or it'll be
it could be and because it's gotta be greater than or equal to, not 10 and less than or equal to 19.
Thank you.
Now, the only thing is, you need one more thing in there. You gotta tell it what less than or equal to 19. You gotta put packages again. Because you gotta have a complete expression right there.
Okay, so it doesn't recognize this as the constant.
Some languages would, but I suspect Flowrhythm won't, but some languages won't. And they're distinct and clear now. So if both of those are true, you know what the situation is.
So it should take the packages down.
Sorry, I'm there, so I'm supposed to do it.
Yeah, but
Create another good statement, or if it's between 20 and 49.
Yep.
So, okay, so I'll have to do, okay.
Does that make sense now?
Packages. And that's true. And do another if. It's constant.
So you see, they can get,
I mean, I've already done this earlier with the first, I created an if statement for if it was 1, if it was 2, if it was 3. Just over and over.
now, actually, when you're doing this one inside there, before you type that,
Yes.
you already know when you get to here that it's not less than 49. Are you following with me? But you've already eliminated anything less than 10 up here, actually less than 20 up here. okay?
So we don't
You
need that.
eliminated less than 49 here, so when you you go to type this one, this packages, you're just looking to see is it less than whatever the next bigger number is. But you can do it the way you just did, the whole complicated. No, not greater than anything, less than. What was the higher number? 99.
Alright, so I can remove this 20 as
You
well.
remove the 20 and the and on that one. First one, you can't get rid of that. You
Yeah,
have to have
because it
the
has to know that it can't go to low tens.
But you see where your logic is building onto your logic.
Yes. And that's what I have down over here.
Now, you actually don't need an if over there.
I don't, oh wait, no, I don't.
Because it's everything else that's left is what you're at. So you can go ahead and do your output, but you know it's greater than 100 at this point.
Well, actually, no, I do need to, because of the fact that, what if they put a 9?
You're right, you do. You're correct. But if it was less than 9, you don't even account for this whole time. You're right.
So what I would have to do is.
Because there is no discount for them.
100 or is greater than or equal to.
And then there's the discount. And what's the discount if none of those apply? There is no discount, right? The output 0. You're then outputting the discounts. Okay. Or no, not 99.
I've been putting it's the amount of the purchase.
Oh, okay,
after-
the amount of purchase.
after
Okay,
this
that's it,
amount.
yeah.
So.
No, because these, you've just been putting a discount on. You're not telling them what the total amount is there when you did
That
those.
is, it's 99 times the discount.
That figures what the discount amount is, because your rate is 50%. So here, you just said, I'm going to output half of 99, so I'm going to output 49.5.
Yeah.
Well, you need plus 99 added on each of those to get the total price.
Why would I add 99? It's a discount from.
Actually, not plus 99, 99 minus that, because in that case, it is half of it. But 99 was how much the purchase was. If it was 20% discount, okay? And I'm going to do this in round numbers, okay? I'm going to assume this was 100 actually, okay?
Okay.
To make it easier on us. So if it was a 20% discount, we'd take $20 off of that, right?
Yes.
So with a 20% discount, how much do they owe?
How much
Not
do it?
$20, it's what?
80.
It's $79 or $80. Which was the 99 minus the discount amount, which was this, which was the $20. You've just been telling me to print that $20. You see what I'm saying?
Yes.
And you got to get it back to the 99 on it. That's why I went up there to draw it on board.
So I need to label all this as discount.
We're off, so I've listed.